Thanks to a $185,000 grant from the James H. Cummings Foundation, the Jacobs Institute of Buffalo, New York has made key investments in a catheter braider and a catheter laminator. Two machines senior R&D engineer Josh Davison says are critical pieces of equipment in prototyping catheters for the treatment of vascular, neurological, and related diseases.
We were not able to make braids by hand before, so having the braider is a new capability for us. You know, we can make a braid that is very big, but to do something that's on, something with a diameter of maybe 1/8 of an inch, that's difficult. So what the braider allows us to do is essentially control the stiffness along the length of the catheter.
We're going to adjust this a little bit.
A strong design of catheter is paramount to a doctor's ability to navigate through the complex blood vessels of a patient and perform life-saving interventions.
The plastic doesn't give enough toughness to prevent, for example, for bursting, but with the braid it can. So the braider that we got has been excellent because it allows us to not only put a nice, very consistent braid down the length of the shaft, but we can also vary different wires, so we can do flat wires and round wires, which will give us different properties. We can vary the density of the braid, which will give us different properties. So a very dense braid would allow the catheter to be more flexible, whereas a not dense braid would allow it to be very, very stiff.
Prior to receiving this grant, engineers here at the JI would have to laminate catheters by hand.
It worked okay, but it was certainly not something that we would want to make a production quality prototype with. What the laminator does is it has a little heat nozzle that goes around the mandrel, and it will slowly go down the mandrel, blowing hot air, 235 degrees Celsius, and what it'll do is it'll melt the plastic and reflow it over the catheter.
This is a critical step in making catheters because of the catheter's braided wires.
You don't want to put that into a patient because you just have a cheese grater going through their vessel. So what we do is we put another layer of plastic on it and we put it in a laminator, and what that would do is give us a nice even reflow of that plastic over it, so when you touch the surface of the catheter it's a nice smooth plastic.
The generous support of the Cummings Foundation has allowed the JI to strengthen our partnership with current I2R partner Spinnaker and attract new I2R project partner Vicora as they develop a specialized catheter to treat stroke patients.
The end benefit for patients is that we can bring products to market faster. In terms of Spinnaker, we use the laminator and braider constantly.
And the JI is the only organization in Buffalo to use this equipment exclusively in prototyping medical catheters for the treatment of vascular, neurological, and related diseases, accelerating the design process to FDA approval, and bringing a new engineering skill set to the Buffalo Medical Campus and the greater Western New York area.
The support from the Cummings Foundation has obviously been critical. The braider and laminator are essential pieces of equipment for making catheters, and it honestly elevates us to that next tier of prototyping house to allow us to assist other companies and bring in more I2R projects, because we can make these products how they're made in industry, which is a huge thing for engineering because you need to kind of meet the standard, and the Cummings Foundation has allowed us to come up to that standard in terms of catheter making.